All right, guys, today we are going to work through some practice problems for our final exam review. These problems are going to help you prepare for your final exam quiz 1 that you're going to have on Monday. This will be a 10-question quiz only over equations and inequalities. All right, so first set of problems, solving equations. We solved similar problems to this yesterday in class, so really what I want to do is we're going to go to each slide and then we're going to pause the video just for about 2 to 3 minutes. I want you guys to solve these problems on your own. So if you have an expo marker and an eraser, you guys can work these problems on your desk. Otherwise, you need a blank sheet of paper and a pencil. Calculators are fine, although we're staying pretty basic with the numbers. You shouldn't really need them. We'll just work through that way. All right, so let's go ahead and pause here for about 3-ish minutes and let you guys work through these equations. Everybody is working the problems, okay? So everyone needs to be working these and solving them, and then I'll explain how to do them in just a minute. All right, so let's go ahead and go through the first equation. Hopefully you combined like terms. All right, so because they're on the same side of the equation, we combine negative 2x minus 4x to make negative 6x. Then we bring down the rest of the equation. Now we're solving this just like a regular two-step equation. We put the heart around the negative 6x, the term with our variable. And now we move the negative 4 to the other side of the equation. We do this by inverse operations. We do the opposite. So we're going to add 4 to both sides. All right, let's bring everything down. Negative 6x equals 18. Did you guys get negative 3? If you did, you're all geniuses. Good job. All right, great job on that one. Now let's look at the second one. We can't combine 2x minus 8. They're not like terms. So hopefully you distributed. Negative 2 times 2x is negative 4x. Negative 2 times negative 8. So number one mistake we see here is mistakes with the signs. You've got to make sure you get your signs right. Negative 2 times negative 8 is positive 16 equals 12. Now I'm going to solve this just like a regular two-step. Put my heart around negative 4x, subtract 16, 12 minus 16. Is that going to be 4 or negative 4? Should be negative 4. So negative 4x equals negative 4. Now, if this were a question on your final exam, you're going to have both the positive and negative options for your choices. So it's important that you are very confident in your answer. Negative 4 divided by negative 4 is positive 1. All right, so solved our first two equations. Let's go to the next slide. All right, so I was really strategic with which questions I picked for these slides. If you are seeing this type of equation, it means it's either going to be on your final exam quiz or on your final exam or both. All right, so these are really important ones to know how to solve. Let's go ahead and pause here for about 2 to 3 more minutes so you guys can work through these equations. Like I said on the last one, I want you to work the equation on your own and then turn to a neighbor and compare your answers. All right, so let's go over our answers here. Hopefully you put your heart around the x over 3, the term with the variable. Now we need to move negative 4 to the other side. We do that by doing the opposite, which would be to add 4 to both sides. 2 plus 4 is 6. And if you remember, all right, division is connected to my variable. The opposite of division is multiplication. I need to multiply by the reciprocal. Cross cancel your 3's. 6 times 3 is 18. X equals 18. All right, so that's that question. Now let's look at the next one. What did you guys notice that was different? All right, hopefully you're thinking, well, I've got variables on either side of this equation. I've got a 4u here and a 5u over on the other side. So my rule says I want to look for the lesser value between the two, and I want to move that one to the same side of the equation. So the first thing you should have done is subtract 4u from both sides. All right, when I do that, I'm moving my variables to the right side of the equation. All right, and I do that so I can keep a positive value with my variable. So negative 5 equals 3 plus 1u. All right, so now I heart my 1u. Even though this is kind of written backwards, that's not a big deal. Now I need to get my 3 to the other side. I do that by subtracting both sides. Negative 8 equals 1u, but I know that's the same thing as just saying u equals negative 8. All right, I can just switch it back around. So that's it for our next two problems. We got 4 equations under our belt now, and we're going to shift gears over to our special solutions. So up until this point, we had one solution in our answers. Now, possibly we would have no solution or infinitely many solutions. If you guys remember, this happens when my variable cancels out completely. So I'm trying to get it on one side of the equation, but then it actually ends up canceling out. All right, so we're going to pause here for about, again, same amount of time, 2 to 3 minutes. I want you guys to solve each one of these. Talk with your neighbor, all right? Kind of collaborate on this. What do you guys think? Do you think it would be one solution, no solution, or infinitely many solutions? Okay, all right, so let's go over the first equation. We have 4w equals 4w minus 5. So we have 4w on either side of the equation. Well, we got to get them on the same side. So in the last slide, we did that by inverse operations, right? So we subtract 4w. Now subtract 4w from the other side. But then it cancels out too. When my variable is the exact same value and they cancel, now I have a special solution. So on the left side, I don't have anything left. It's just 0. On the right side, I bring down my negative 5. Well, do those equal? No. No solution. Okay, so hopefully you guys have had time to work the second equation. Distribute a property gives me 4x plus 6. Oh, well, that's kind of interesting because that's literally the exact same thing that I see on the other side. So my 4x's cancel, right? I try to move them. Yeah, of course they cancel. What's left equals 6 equals 6. This is infinite solutions, because what's left equals out. All right, so we went over regular types of equations, combining like terms, our special solutions. The last type of equation we're going to go over are your equations with radicals. Now, this is actually pretty recent for you guys because we learned this in chapter 9. All right, so we just had this test. So the only difference here is I've got those exponents with my variables. Remember, I do the exponent last. I take care of the exponent last. So put your heart around the 2x, right? And I want you to keep solving both equations. So again, I want you to just work through the steps and solve these equations. Okay, so did you subtract 12? Hopefully you subtracted 12 next. And you got 392. Next step, divide by 2. And x squared equals 196. So the nice part about this is it's a perfect square. I'm sorry, not 192, 196. It's a perfect square. So 196 is a perfect square. When I take the square root, I get 14. So one small detail here, guys, and it's a small detail, but it's going to be the difference between a right and a wrong answer. I took the square root. So technically, negative 14 is also the correct answer, because negative 14 times negative 14 still gives me 196. So if you guys remember back to your big ideas homework, there was 2 boxes for your answer, and that was because there was a positive and a negative. All right, and that's only for square roots. So you might have forgotten that detail, so that's just a reminder for you. All right, let's look at the next equation. So good thing is I don't have anything else connected to G. So all I have to do is inverse of the third power. Hopefully you guys did the cube root. Did you write the tiny 3 up in your radical? That's telling your reader you understand inverse operations. So the cube root is important on both sides. And then G equals 8. Because everybody has that memorized, right? The cube root of 512 is 8. All right, so that covers equations, guys. We have now covered, now this is just round 1 of it, but we've covered every type of equation that you're going to see on your final exam. And now we're going to shift gears over to inequalities. When you solve inequalities, it's pretty much all the same rules as equations. Obviously, we do know that we have one small exception, and that's when I have a negative connected to my variable. So we're going to pause here for another minute or 2, and I want you to solve the inequality. Then I want you to graph the solution. Remember, we do that on a number line with the solution in the middle, open or close dot, and then your arrows. All right, so we'll pause here so you guys can solve this inequality. All right, so first step, divide both sides by -2. So did you guys remember to flip your sign? If a negative is connected by multiplication or division, I have to flip my sign. So now open dot on -8 with an arrow going left. All right, so that's really important for you guys to remember how to do. Now we're going to write some inequalities. We're looking for keywords in these statements that'll tell us if it's a greater than sign or a less than sign, if it's equal to. And we're going to set up our own inequality statement. All right, it says a baby panda. First of all, I made up this problem, so don't Google search. It's probably wrong. All right, but a baby panda weighs at most 15 pounds at birth. So according to this statement, a baby panda, all right, so X would be all of the weights that would make this statement true. So at most, what sign do you guys think stands for at most? All right, so if you're thinking less than or equal to, if something is at most, it means it cannot exceed that value. You can't go over it. So that is less than or equal to 15. Now let's look at number 2. A person must be at least 18 years old to vote. So what would be the acceptable ages? All right, so X stands for all of the ages that would make this statement true. So do the ages need to be less than or equal to 18? Greater than or equal to 18? Is it not equal to? What symbol would go there? All right, so if you guys are thinking greater than or equal to, you are correct. So we're just writing statements. On your final, it'll be a multiple choice type of scenario. So I'm going to give you the scenario, and then you would choose the correct choice for the inequality statement. Now on the next one, you're going to give any value that would make this inequality true. Well, the first thing you're going to need to do is solve the inequality, so then you can give me some kind of value that would make it true. All right, so I want you guys to solve this. 4x is greater than 32. We're just going to pause here for a minute. Solve it. Now give me any value that would actually make this inequality true. Sorry about that. All right, so let's divide both sides by 4. X has to be greater than 8. So here's what I'm trying to do here, or what I'm trying to reinforce with you guys. This statement right here, this X, this is all of the acceptable answers. As long as you give me a value greater than 8, it's going to make this inequality true. All right, let's take 10 for example. Is 10 greater than 8? Yes. So plug it in. What's 4 times 10? It's 40. Isn't it true that 40 is greater than 32? So as long as you give me any number greater than 8, then you've answered the question. Any value that would make it true. Could be 9, could be 10, could be 15, could be 500, as long as it's greater than 8. All right, so hold on one sec. I just have to regain my slide here. All right, that was weird. It just kind of froze up. Sorry about that. All right, last slide of the day, right here. You're going to write the inequality that is represented by the graph. All right, so for each one of these, we always want to write our variable first. All right, so let's start with the orange one. So we start with X, and according to this arrow, would it be greater than or less than? All the acceptable solutions, that's what X stands for. All the acceptable solutions for this one must be greater than or equal to, because it has a closed dot, 7. X is greater than or equal to 7. All right, I want you to go ahead and we're just going to pause here for another couple minutes. I want you to write your inequalities that are represented by the other two graphs. Okay, so for the second one, did you say X is again greater than or equal to -1? And for the bottom one, did you say X is now less than or equal to 50? So just simply being able to write an inequality statement from a graph. All right, in Algebra 1, we kind of go a little bit deeper and you're actually going to make up your own inequality to solve. But for now, we're just writing the statement that goes with the graph. All right, so that's going to complete our review for today. If there's time left in class, I need you guys to get out your final exam review sheets. I need you to start in the back of the packet. All right, so that's a lot of the more recent things. You've got exponents in there. You've got your rational numbers. You guys should definitely be able to work some of those problems. So I want you working on that for the rest of class. No homework over the weekend. And that'll be it for today.